Hi everyone, my name's Desiree and today I'll be talking about Lego counting 3 different ways. This is part of my final project for Data Science CSCI E29, and over here on the slide you'll see all the wonderful staff members from our course. A little bit about myself. I am a principal value consultant for Genesis Telecommunications. I've been working in the business intelligence and data visualization space for about 10 years now, doing a lot of the work that I do in Tableau, as well as in Excel and mostly descriptive statistics work. One of the things that I really enjoy doing outside of work is I love to cook, and my husband and I, we host 5 or 6 families every other week for dinner over at our place. I don't know about you guys, but I have a 5-year-old and we have a lot of Legos at home. We have the big box and we have kits. Kits build things like boats or cars. And I do like to make sure that we have those pieces together before putting them away so that they don't get absorbed into the big box of Legos. So instead of counting them by hand, I thought I'd try and see if I could put together a machine learning algorithm to count up how many pieces there are in an image. The target audience is people who are beginners to machine learning image processing. There's nothing too sophisticated here, and the accuracy could be improved on. In addition to that, people with Legos that need to be counted might be interested in this algorithm as well. The methods that I used are below. Template matching sounded very promising but didn't work out because you needed to have an exact image match for it to find it. So these are the 3 I settled with. And here are the list of libraries and files that you'll need to run this code. The first method that I use is the same as we used in problem set 5Q5, where we take the average number of pixels per piece, which was given to us in the problem set, but I calculated over here to be around 750 pixels. And by clustering the centers, finding out which was the background color versus the colorful part, taking the colorful part and dividing it by the number of pieces, I got the average. And then doing that again with a new image, but dividing it by 735, which was my previously calculated number. I get 7.6 pieces, and the result's pretty good. There are actually 7 pieces in the second image, and I predicted 7.6 based on this. For method 2, I used a contour finding package in Scikit-Image. So this is a really neat package. If you take a look over here, I don't understand how all of it works, but it does try to find edges of things that have a constant value. So it will look for things that are the same color and then put them together. So this is sort of what the example looks like. And if you implement it with the Lego pieces, this is what we get, which is really neat. You can see over here, you do have to use a grayscaled image, which I did, but the yellow piece turned white. So perhaps looking into some way that it could use colorful pieces as well. Now, I wasn't able to set sizing over here. So as you can see over here, it thinks there's an extra piece over here when it's really just part of another piece that's already here. And in this case, it took the 2 pieces of the shadow instead of counting this as 1 piece. So we did end up with 13 predicted pieces as opposed to 11, which is the actual number. The last method that I tried, I'm calling this label connect. What it is using the Scikit-Image measure library. There is a function label that allows you to label the same sort of in a neighboring kind of way, label the same valued pixels together. So using this label function, finding the clumps, again, similarly to the contour finding, but basing it on the actual value in there, to color value to group objects together. So using this method, I was able to set the minimum and the maximum size, which helped with the noise. And over here, I think I got the best prediction of the three. The number of pieces predicted here is 10. One problem is that we had a shadow that was overlapping with part of another piece, and so these two pieces here, the algorithm considered that one piece. So while doing research for this project, I did come across this Count Things app on the iPhone. What it does is it takes images and then counts up how many things of that kind are in this image. They have some different templates for agricultural as well as construction uses. So I think it's a pretty useful thing, and I wonder if they're using some of the algorithms that I described here. Here are just some of the references, and quickly acknowledgements. Phil, thank you so much for your words of encouragement throughout the semester. And my son, pictured here, Adam, for always reminding me that difficult things make your brain grow, as well as my husband, Mahmoud, who's done everything. Thank you, everyone.